guest speaker today, and he's going to give us a whirlwind presentation on advanced packaging, substrate, and ultra HDI updates from his experiences from working with companies and consultants around the world. Gene is, as I said, president of Weiner International Associates, which is a business and technical consulting firm which has been serving the specialty chemical, materials, and electronics industries for a number of years. His clients have included several Fortune 100 companies, and he started in this industry back in 1956 at MIT Lincoln Labs, where he produced the first printed wiring memory plane utilizing additive processing and 3D imaging through planar mask. He introduced the first aqueous processing dry film resist, alkaline etchants, and other industry first, and was a founding partner of the Quantum Solar Group, a market research organization in the photovoltaic solar industry. Gene has held a number of executive positions prior to starting his own firm. This includes director and president of New England Laminates Company, which was a leading supplier of copper-clad laminates. He was vice president of sales and marketing of Dynachem Corporation, which is one of the world's leading suppliers of photopolymers and specialty chemicals to the electronics industry. And he also served as vice president of marketing for Oxy Metal Industries, which was a subsidiary of Occidental Petroleum. He has also served on a number of community boards, including the Plymouth Philharmonic Orchestra, and chairman of the advisory board of directors of FIChem, which is a publicly traded specialty chemical company listed on the Shenzhen Stock Exchange. Gene has also been involved with the Malcolm Baldrige School of Business at Post University. Gene is a member of IPC, SMTA, the PCBA, and is an honorary member of the EIPC. Gene has received numerous awards in his career, including the IPC President's Award and also the industry's highest award, the IPC Raymond E. Pritchard Hall of Fame Award. We are happy to bring to you today Mr. Gene Weiner. Gene, thank you, and take it away.
Thank you, Mike. What a great introduction. It's a pleasure to be speaking to all of you. Good morning, good afternoon, konbanwa, depending on where you are. Never in my life have I seen so much attention focused on a single topic, which is advanced electronic packaging as we see today. It seems there is a new meeting, display, conference, or exhibit on the topic around the world almost weekly. Next slide, please. Next slide. There we go. When Larry McCarthy of the HDP asked me to look at things in the industry, he submitted these suggestions. And so we tried to do that. But once we got involved with the topics, we found there was far more than could be presented in a single hour. So we'll do our best on a whirlwind tour around, knowing that there are many other things that can be provided, can be done, and are happening. Next slide, please. Generally, the presentation, not necessarily in this order, is going to include what's happening with funding, what's going, new and emerging substrates and materials. You're going to get a nice presentation from AGC later today. A visit to one of the facilities already engaged in UHDI and HDI that received funding for a new facility. Actually, there are two of them. How you test these new boards, an example of a test board, an update on a smaller, not a giant company that has already established itself in the UHDA market in both rigid and flex, an update on build-up filled glass substrates, something new in the industry from the top down, from the semiconductor side. Next slide, please. An update on Schmid, which was requested on where they're going with their new process, latest technology for via formation, large format IC substrates. There's not much available. We'll comment on that. Test vehicle was mentioned, and something new that is applicable to not only UHDI, but the electrohydrodynamic deposit screen printing system developed by Scroner in Switzerland for feature sizes down to 2 micron. Very interesting by screen printing. Next slide, please. Well, when we look at this, organic substrates are the key to today's manufacturing. And there, as we say, there are many roads to the mountaintop. Most of today's processes in Asia and here for high density and ultra high density use a modified semi-additive process with electrous copper for building up layers, and they use an intermediate buildup film called Ajinomoto buildup film, or ABF. Although they're quite applicable and perhaps even better, direct metallization, direct preparation for electrolytic plating includes carbon or graphite deposits, probably graphite the best, but the adoption has been slow. People are reluctant to change when things are working, but they change when they get new lines or have new applications. Next slide, please. Now, what's gaining a lot of attention right now is one is the use of metal inks for depositing cedar conductive layers in bare substrates. For example, the one that was originally developed by Veritech, the company changed the name, and is used by, for example, by Calumet and by, we'll say, not only Calumet, but American Standard Circuits. The next is the sputtering of titanium or copper, basically titanium on the base materials for making parts conductive for subsequent electroplating. And this is where one company in Switzerland, Secor, adapted a process using Plasma's equipment with a titanium seed layer followed by copper, and established it with a couple of lines in China as well as Switzerland. But this is where, as we will see, Schmid is making a big move with their own process, which is seems to be an advance called ET. So we're going to go on to that. But if we look at the different inks, next slide, please. When we took, next slide, please. This is just promotional and that type thing. LQDX is the one that was originally a Veritech, and they just signed a new agreement. This is quite interesting with liquid metal inks with Kansai Denshi Industries, its partner, to produce IC substrates. KDI has been producing PCBs with HDI circuitry with 30 micro lines and spaces for some time now. Other suppliers, the one not well known is ChemCube in Long Island, has a range of inks which include silver and copper and metal inks, and they also have their inks are called Electrojet. They also have a machine supposedly in test at one of the major American facilities right now, believed to be TTM, using electron inks for additive manufacturing, semi-additive manufacturing. They seem to have a low sintering temperature and a lower sintering temperature than the conventional paste. An interesting thing here that we have not yet seen much of is the potential use of flash curing, the use of flash lamps or xenon source lamps by such companies as Postforge and Round Rock, Texas, as well as Xenon in Massachusetts, to sinter or cure these things in milliseconds rather than seconds or extended times. Next slide, please. Here's an example of some of the panels produced by American Standard Circuits. They're in production, 20 micron line in space now, and they state that they will be producing 12.5 micron line in spaces by the end of the year. Next slide, please. We won't dwell on this, but the design advantages are here. You can look at this later when you get the slides after the presentation. Next slide, please. Now, one of the things that's necessary for success in this, I firmly believe, and we will see throughout the presentation is the need for collaboration between companies. For example, several members of the HDP such as Resonac and KLA are heavily involved in collaboration with a variety of companies. KLA has made a recent announcement on this, and the range goes beyond just the printed circuit materials. Some of the companies that supply both industry semiconductor as well as printed circuits are heavily involved in this, and we'll see some of that as we go on a bit further. But Electron Inc. has just signed an agreement. This is from Round Rock, Texas, one of the newer companies links with Scrona, who developed the first electrohydrodynamic multinodal printhead capable of printing down a 2-micron line in space. By the way, they are marketed and partnering with a company called Notion Systems, which is producing the actual delivery systems for these with their printing systems. They've just sold 2 of the newer systems in Italy capable of doing very fine lines with solder mask. Notion Systems primarily is known in our industry for its use of printing with solder mask. Next slide, please. Now, this is a question. Will ABF be the new Kleenex term? Kleenex or Jeep? Widely known, and in the modal buildup film, known as, universally as ABF is over 90% of the market. What was not well known was the second supplier in Japan had about 5% of the market and used apparently the same coding system that Anjimoto did. But the material has only recently had new competitors, not only in light technology, but in dissimilar technologies and that compete. One of these will be presented later today by Asahi Glass, which is a new super thin copper on resin film for buildup processes, as well as a material that would directly replace the ABF material. Another group of materials has been developed by Taiyo, which includes an unusual one called a photoforming film, which can be used to, like a photoresist. This is being tested in a company in Japan that would replace the need for laser ablation or removal of the buildup film to reach intermediate layers. Next slide, please. So we wonder, what are they all going to be called? Next slide, please. Now, AGC has got a product that was, or a series of products that actually developed in the U.S., unlike many of the others we're seeing around here, in the Fast Rise group of materials. And they have, next slide, please. They've developed a non-reinforced material as well as the copper clad material with pretty good materials. Next slide, please. That with low CTEs, that'll match pretty good. If we look at the family of resists on this thing here, you will see that they have material there for their ultrafine UHDI systems. Next slide, please. I want to thank Paul Cook of AGC for providing these slides. By the way, a number of our slides were provided, and we want to thank Bob Ferguson of Schmid, president of Schmid America, as well as Steve Karras and Jim Brown of Green Source, and Brian Bouya, president of Remtech, and we'll see that later. Let's move on here to Schmid, if we can. Next slide. Now, Schmid states that there are 3 major processes in producing them. We're all familiar with the SAP, MSAP processes. Their new material or process is called ETS. It's a cordless buildup based on MSAP or SAP concept. Main difference is they've built the first layer on a support sheet by structuring and plating, and they're doing this by plasma. By the way, Schmid has got a lot of experience, over 100 years in dealing with glass, although they have not yet introduced a process for glass. Next slide, please. The new process that we found that they're promoting with an installation in China and Europe, and they state they have their first customer lined up or in test, is their coreless process, which is the buildup. It's using a single or double-sided process, the plasma system. Next slide, please. It gets so down to 1 micron line in spacing, 3 micron spacing. It's rather phenomenal, but these plasma samples developed by plasma processes are not yet commercialized. It'll be interesting to see how this proceeds. It's a revolutionary process. It's been in the works, and their first U.S. system will be soon, I'm told. The name of the company is confidential at the moment. Next slide, please. There's another group in that on the line. By the way, there are approximately more than 100 lines in HDI buildup and moving into UHDI buildup out in the field by Schmid, which covers all forms of photoresist processing, cleaning, developing, and so forth. Next slide, please. And these are the tools, what the system is. You can look at this a bit later. They have equipment for all of these processes. Next slide. Pretty good cleaning. Next slide. Oh, by the way, they use an MEC adhesion promoter. MEC is coordinated with Resonac and with Umura in developing processes for UHDI, and we'll see that more and more through their slides later. This is the picture of the plasma material system that Schmid is promoting. They are prototype, not yet in production. It differs somewhat from the one produced by and used by C-Core, in that Schmid is also working on putting copper down directly onto the substrate and on glass, as well as the titanium bonding intermediate layer commonly used by others. Next slide, please. Here's the details of the tools. You can look at this when you get your copy of this. It's quite unusual. There is a question on the bonding of the copper direct deposition without a titanium bonding layer. However, as we'll see when we talk about glass, that may be solved by the use of diazomine or some other similar bonding agent. Next slide, please. Excellent examples. Next slide, please. We were asked to look at large format substrates. There's not much available on that. We know that TSMC is putting an awful lot of effort into that in their operations in Taiwan. But Mitsubishi Materials believe that they're in the game, and perhaps even with a larger sample than TSMC. But we'll have to follow this. I'm sure we'll see more about this for getting higher yields in the substrates for chiplets. Next slide, please. This is what's being promoted by the IPC, from silicon to system. And it's the right thing. It's a top-down as well as bottom-up type thing. And if we look at it, I come in the middle and I look up at the semiconductor people. Then I look back down to the supply chain for the printed circuit fabricators or organic substrate fabricators. So that's next slide, please. So what we find suddenly is that a guy named Dr. Sam Salama was the vice president of Intel, been there for more than 15 years, decided that he saw the advantage of and the need for substrate production in the United States, especially organic substrates with UHDI. And he founded a company called Hyperion, got some seed money, and he bought 25 acres near TSMC in the Amcor facility in Peoria, Arizona. Next slide, please. And he gave a paper on what's going on with the vector technology and how the competitions are changing and the needs for production in the United States, which only makes 1% of the world's advanced packaging systems right now, only 1% in the US, and 4% of the printed circuits. We have to do more here. Next slide, please. So he talked about the scaling of the state of packaging and substrates, and he decided, next slide, please, that what is needed in the United States is a company that makes both silicon carbide interposers for heat transfer as well as organic substrates. Next slide, please. So he's partnered with companies in Japan and I believe with a company in the US now. Next slide, please. And is now providing samples of the interposer as well as organic substrates. I'm sure we'll be hearing more about this in the near future. I plan to meet with Dr. Salama again during the second week of November in Arizona. Next slide, please. The growing demand, it's actually astronomical, not only for defense and security and medical, but the huge rush to get more on a chip on a board because of AI, of artificial intelligence, and the need for more power, faster circuits, shorter lines, tighter spaces, et cetera, et cetera. And actually what's happened here is in this industry, we're finding that the market for exposure systems, next slide, please. There's a cost thing here. There's a lot of issues with glass. We're going to go on to it. Next slide, please. And this is where he's going here. And next slide, please. And next slide, please. We'll go on to glass substrates in just a moment. But I mean, speaking of glass and on UHDI, the need for exposure systems has exploded of very fine tolerances. You can no longer, we don't want to use a stepper with a mask and so forth with a small surface area and a really exorbitant price. So what we find is that there is now approximately an $850 million market for fine line resolution exposure systems. And that's a phenomenal amount. The key players in the exposure systems on the global direct imaging system, and we're talking direct imaging, KLA, Tech Technology, Small Machining, AdTech Engineering, Screen PEE, a couple in China, Ascent Technologies, Lamada, Visitech, Miva Technologies, Adeon, among others. It's absolutely astounding. And this is the current market is estimated at about $850 million. One of the ones that I found interesting is on the direct imaging side with the micro mirrors was the one produced by Small Machining, in that they developed a system in coordination with Fraunhofer Institute for automation and registration on surfaces, and can produce, they state, down to 6 micron line in space with their equipment, as well as down to 2 micron line in space when you're using a liquid resist. Somewhere around 6 micron line in space seems to be a break point with the micromirror type systems, where you have to go to a liquid resist, which would probably be a positive resist, because the negative resist is subject to aerial oxidation if you don't have a mask on them. So the Small Machining has an interesting thing there. But if we go a bit further and we look at this, a lot of these, by the way, we'll say cooperating or partnering with American firms. KLA has a system that that deals with the glass from the semiconductor side, as well as down on the printed, up from the printed circuit side with fine line resolution. We'll talk about that a little bit later on. But I originally thought glass would, if it made it, wouldn't be around until in volume to maybe 2029. It looks like we're going to see some production in 2025 and accelerating to mass production in 2026. Next slide, please. Here's an example. This one just developed. Again, they have a surface treatment. That's one there in Korea. Next slide, please. And then Philoptics introduced Trinata, another one that they claim has a process for laser drilling, micro holes in semi-finished glass substrates with copper plating. That one was unusual, and they're now forming partnerships, I say, with key glass suppliers. I'm not too sure what that means. We have to look into that one further. And Simtech has been well known for their HDI production and printed circuit production for well over 20 years, is now working glass core technology for use with its flip chip line. Next slide, please. AccuLaser jumped into the market, formed a new company called HDP Solutions, and they say they're going to produce glass core substrates using direct plating mass production by Q2 next year. What they call direct plating, I'm not too sure whether they're going to use an ink or a carbon-based material. That remains to be divulged and seen. But they also are using a hybrid bonding material, again, which I suspect may be in the AZID family. All of a sudden, everyone seems to be jumping on the same thing. We used to use a similar material in the production of dry film photoresist as a bonding agent to help it stick to copper surfaces. Next slide, please. Group Up. This is an interesting one. They've been well known, I should say, for reverse engineering and printed circuit equipment, as well as developing their own printed circuit equipment. And they've moved in recent times into trying to make equipment for semiconductor packaging and glass offerings. I don't know what that's about. I can remember being approached by their management asking me to buy a particular piece of Western equipment so they could reverse engineer it and improve it, they said. So that was the last time I had a civil conversation with that group. The next generation of substrate, this is from a guy that consults to the semiconductor companies and fabs in Taiwan. And he states that the next production UHDI substrate will have a buildup film on glass treated with a silane coating. And he says that one Taiwan toolmaker already established a silane coating line, a pilot line in Arizona. We've yet to find out who that is, but that's going to be an interesting one to follow. Next slide, please. Another test and certification for resistive. This is just more or less materials for ultra UHDI or glass. Next, but they come to have a protective coating, and that prevents substrates from cracks based on liquid solar panels. I'm not too sure what that's all about. Solar panels are much heavier and thicker and of a different type of material. This is another interesting thing to follow. Next slide, please. Now, Dr. Speisman is probably one of the best experts in the world in both metrology as well as inspecting, and now moving into the ultra high density range. And she's been speaking around the world on the topic and graciously provided the following slides. Next slide, please. KLA is one of the companies, next slide, please, that's both of the semiconductor and basic thing, and they have developed processes for processing glass as well as UHDI and formed partnerships in the U.S. By the way, I've seen some of their work at one of the UHDI facilities I attended, and it's quite interesting. Next slide, please. We're aware of this. The glass core IC substrate is a big future one for them as they continue to semi-dominate the UHDI and organic ones in the U.S. Next slide, please. And these are the products they have. Next slide, please. These are the challenges. We can all read about them. Next slide, please. This is interesting. Their laser system can go down a 2-micron line in space. They also have a system that can repair 2-micron, sorry, not 2 mil, lines of copper lines and systems. Next slide, please. They use a multi-wavelength laser technology that matches up with the resists. By the way, the modern resists for this type have multiple response frequencies with the photo initiators in them. Next slide, please. I-line and H-line are well known to the semiconductor people, and they'll be used in some of the materials being used for printed circuits. By the way, Resodac, who is involved in both the printed circuit and the semiconductor side, formed a collaborative joint venture with 5 American companies for advanced packaging to be set up in this California area. And on the printed circuit side, they provide everything from photoresists, dry film photoresists to substrates and plating solutions. Next slide, please. And 10 micron line space. Next slide, please. They have the metrology and inspection. We're going to talk about it, metrology a bit later, inspection too. Next slide, please. The handling right now and the through glass via formation, I think, is about to be resolved by multiple companies. The handling issue is what that remains to be resolved and will still be an issue to prevent it from cracks and other issues. Next slide, please. Next slide, please. Hybrid bonding is something that's going to be interesting when it comes in when the things with the glass core IC substrates. Next slide, please. As part of the investigation of this, I decided that I want to go visit one of the companies that's already making UHDI circuitry, as well as a recipient of $47 million in grants and is going to build a greenfield facility. When people do this, we know, for example, TTM received about $47 million, but will spend the cost to build the facility in Syracuse, the greenfield security that will employ hundreds. It will be about $100 million, and the suspect Green Source's total spend, including the grant, will be similar. One of the interesting things about visiting this facility at Green Source is that I thought they were only producing HDI substrates, but it turns out they were actually making UHDI substrates in production. I saw it with 20 micron lines and spaces, and they have a system which can inspect 1,000 data points in a large panel in less than an hour and load all the data into their system. Next slide, please. That was amazing. 1,000 data points in less than an hour. Next slide, please. One of the things that we talk about in the IPC, and I'm sure everywhere else, is the outreach to develop a workforce of the future. There are too many of us gray heads and white heads around, and not enough young people. This company is filled with a complete range of senior people all the way back down to young students that have come in there. They engage heavily both with a women's engineering group, local colleges, high schools, invited people in, and I encourage all companies involved in this to do so. Next slide, please. This is the current capabilities that they're producing. Next slide, please. Next slide, please. They have a roadmap. The company's roadmap will put them in full production by 2026 in the new facility. But an interesting thing, next slide, about this company is that they will go back to the trust but verify mode on quality, in that as they stabilize systems, they trust what they do, but they're continually improving and working, so they keep trying to verify the modifications. Their primary system will be MSAP for the new facility with electroless copper, which is what they're doing here, but they also run an experiment in parallel, other versions of additive and semi-additive manufacturing. So they have a primary and have a backup developing one. Next slide, please. Next slide. They actually gave the fabrication phase one floor plan for the new facility, which you can look at later. Next slide. And they're interesting in that they have a zero liquid discharge, and that was what they were known for. And they build a lot of their own plating equipment. They are one of the first people to take the small machine and double laser system in. First it was manual. They now have several automated systems in for HDI, UHDI production. Next slide, please. One of the surprises in investigating all this is that UHDI was not just for organic or glass substrates. I heard of a company making printed circuit boards in New England based on an article in the Boston Globe. And I said, in Canton, Massachusetts. And I said, no, there's no printed circuit company there. So I investigated. It was a hybrid company. And it's called Remtech. And I called up the president, Brian Bruglia, and told him what I was doing and asked if I could visit. And he invited me over. Next slide, please. And next slide, please. It turns out that in thick film processing and in the manufacture of, next slide, please, of critical hybrid power circuits that take for defense and military and medical and other high reliability, high voltage applications. Next slide, please. That Remtech has been around producing HDI as well as normal systems with a patented process they have for plating copper on thick films. Next slide, please. And it's pretty much about the way they both have a screen system and a photo etch system. Next slide, please. And next slide, please. You can see some of their work here. And they're very much involved in advanced packaging, especially with ceramics are involved. Next slide, please. And I was surprised to learn that they're already in HDI systems with the microvias less than 5 mils in diameter, coming down to 3. Next slide, please. And they have a program in place to move into UHDI on hybrids, on ceramics, which I had was unknown before. And if we look down there on the metallization thicknesses and interconnection lines in the program, where they're current and where they're going, we can see that. Next slide, please. Now, when we look at all of the things going on and in all of these companies, you say, okay, we're going to produce UHDI circuitry. How are we going to test it? We've got type 6 solder paste out there. We've got type 7 being tested coming along. And we need some form of test vehicle. Well, the SMTA helped work. Chris Shea from Shea Engineering developed a test board, which is shown here. Next slide, please. For testing ultra high density, the printing, the placing, reflow inspection, the use of fine solder and powder tests. Next slide, please. And assembly tests, and it can test all of these printing challenges and assembly challenges for ultra high density. And they're all described here. And if we look to the left of this, we see that black area. Next slide, please. That's where the tabs are. Some additional circuit tests are being placed on the new design currently in the works. These are the tests that we could go through on the with this particular panel. Next slide, please. It's available, I believe, from Shea Engineering and the SMTA. And they talk about how the structure is here. Next slide, please. All right, this is the end, but it really is not the end. This is the beginning. As we sit here today and as we discuss all of these systems, we find that there's things that are being introduced almost daily and spread around and shared and with cooperative ventures. The cooperative ventures range from those. Oh, by the way, there's more going on in the U.S. than we think, and we didn't mention, for example, that FTG is going to get into the business and we'll be partnering with several companies. We know that Schmid is talking to all of them. We know that KLA literally has hundreds and hundreds of systems involved in this for tests, for measurement, and both on semiconductor side and the printed circuit side. We know that Resonac is partnering and also has a special dry film photoresist that's useful, formerly the Hitachi company, Hitachi Kasei, that's useful in imaging this. We also know that AGC, Asahi Glass, has a material which is designed especially for ultra high density and high density material, and it's sold in the U.S. through a distributor chain now. I suspect and wonder why not that doesn't become part of the Asahi Glass organization in the U.S. soon. We also know that there is a lot of work being done with the metal inks, and we expect to see more of that. I'm surprised that more people have not attempted to use these. Now, the EHD system promoted partnered with Scroner, for example, and Electron Inks, and as well as the former Veritech, show great promise in addition to these things. The ultra-thin copper foil on resin, unsupported resin, once again brings back a renovated but improved old technology with a new twist for ultra high density, for example, the Asahi Glass material. The photo imaging of a bond ply layer also is interesting in that. The use of fillers in these materials to change the CTE is becoming a science in itself. And what is probably needed is a pre-preg or material that doesn't have to be kept frozen and have a longer shelf life to be of use in the industry. In addition to that, there needs to be more robotic work on the registration and handling of these materials for assembly on the assembly side. When you get an ultra micro BGA board coming down the line, how are you going to place those components? I don't know if any of the existing equipment that's high speed can do it at this point. There's also need for repair, for detach and repair systems for these boards as they come down the line. By the way, one of the important needs to get yields on ultra high density is to monitor, inspect, and test all along the way and either correct or remove defective parts without adding value prior to getting to the end. This is something that Green Source does, and I'm sure others do. With that, I will wrap it up and say, are there any questions? Is there more? There's so much more to talk about, but I think we should be interested in watching the developments with the plasma systems and the new build-up systems of the EHD, as well as the metal inks and the substitutes for ABF. Thank you.
Thank you, Gene. We have time for some questions for Mr. Weiner.
There's a lot of topics here, a lot of topics. Middle links from Veritech. I think Veritech's on their third company now. Before they were Veritech, they were something else, and now they're a third company.
Yep.
I'm a little skeptical of the Veritech because the companies that we've worked with that have used the Veritech have struggled.
I am skeptical of everything but I believe everything is possible. As I said, there are many roads to the mountaintops. I think when we look at these, there are going to be dropouts. There are going to be winners and losers. We know that the former Veritech, it's a new name now, is successful working with C-Core and with American Standard Circuits. They apparently have found a way of making that system work with their own proprietary techniques. It seems that every person getting into ultra high density in the Western world is developing new techniques for using what they have and trying different things. The old tried and true from Asia is using electrous copper, but this gives issues. When you deposit electrous copper, which is what we call a modified failing solution, where copper is reduced from ionic state to metallic state by reduction with formaldehyde, actually paraformaldehyde in solutions. What you do is you generate gas bubbles, hydrogen bubbles, and these can block if you're not careful in processing. So that's why I think inks and graphite and other direct methods of metallization are the wave of the future. Did anyone listen? I guess I confused everyone.
Gene, can
Michael
you?
Baxter has his hand up.
Yeah. So, sorry, I thought I was playing by the rules. I'm the new guy. So one, will your presentation be available on the website? Eventually, I noticed it's not there yet.
Yes, it will be available on the website later.
Okay. And then can you comment on, I recently heard the two North America-based companies that are providing or, looking at competing with the ABF?
The American-based companies, the only
Yeah.
one I know that's American-based really was purchased by the Japanese, which is Asahi Glass in Arizona. They developed the materials here in the States, and I think it's with the help of the financing of Asahi Glass later, have been strengthened on that particular thing. There were other companies that sell materials, but if we look at Tayo America, again, that's a Japanese-owned company. Their process was developed overseas. There were two developed in Japan. I understand there are several being developed in China, but I don't have access to that right now.
Okay, yeah, I was thinking of like Thintronics and ACCM.
I haven't seen anything from there.
Okay.
If they have it, it's not public yet. If we're looking at companies are moving into, there are several, there are very few major companies in printed circuits in the U.S. anymore, and in Europe. We know Verth has closed a number of facilities, and we'll be looking at coming to the U.S. market. But if we look at the big players, where is Sanmina? If I were to guess, I would say they are involved in it in one way or another.
Thank you, Gene. Anybody else looking for some raised hands, or just unmute yourself, and I'm sure there's some more questions.
I haven't figured out how to raise my hand here. I don't know much about the European companies, Schmid and C-Core. If you could just summarize what's going on in Europe a little more, because maybe I'm just ignorant of what's happening in Europe.
Yeah, there was a major move in Europe, but much like in the U.S., like the U.S. PCBA, the American Printed Circuit Board. I'm sorry, PCBAA, Printed Circuit Board Association for America. There was a meeting about 4 or 5 months ago and a call to do the same thing that we're trying to do here, to reconstitute a supply of critical materials to Europe, but at the same time keeps falling apart. They don't have suppliers. One of the last laminate facilities in Europe is closing. They're in a similar boat as the U.S. They do have a similar CHIPS Act type of activity going on. There was a meeting with over 100 companies that are promoting the equivalent of what we're doing here with the Printed Circuit Board Act, trying to get through Congress. If we can get Congress's attention, the PCBA is actively promoting that. I think a lot of our help is coming from Japan and Taiwan right now more than Europe, and Europe is good in. For example, they've developed a lot of the good equipment for exposure systems, for direct exposure, for robotics, and so forth. But they're in dire straits too. And I would suggest that the cooperative thing be strengthened between the U.S. and Europe, and it's already strengthening with Japan. We find that Japanese companies are stepping up to the plate, such as Screen and so forth, trying to look at our market here, and Resonac especially.
Specific to Schmid and Secor, I mean, AT&S is obviously very well known. How do Schmid and Secor fit into the whole dynamic?
I couldn't hear that when it was.
I don't understand. I don't know much about Schmid and Secor. If you could give us a little background of those companies.
Oh well, you could very easily, if you will send me an email, I'll send you a list of the members of the EIPC, of the European Institute of Printed Circuits. It's a relatively small group. A number of Americans participate and are on their board, including someone from Tayo, I believe. We can get that information too. Just send me an email. But there's a man named, was it Weiss? Yeah, Weiss. Puts out a report on the status in Europe, and he posted on LinkedIn a long tome about the dire straits of the European market, and I could reference that to you or anyone else that's interested. Just send me an email. Just put down EIPC. I put down HDPUG as a subject line, and so I'll pull it out of my spam folder, and I'll send you that information.
Yeah, Gene, for others, this is Mike Carano. That gentleman that Gene references is a gentleman by the name of Dieter Weiss, and he does a lot of work.
Dieter, yes.
Dieter Weiss. Yeah, he does a lot of work on markets in Europe, but both assembly and circuit board. So kind of like a market research firm.
I have a lot of stuff. I had lunch with Dieter in Massachusetts actually about 3 weeks ago. He was here on vacation, and we managed to get together. And he is now the key guy on the contract IPC for generating market information on the EMS industry in Europe also. But just send me a note, and I'll send you his stuff.
Yeah, and Tom McCarthy. So Schmid is for lack of a better term, they're a long-time family-owned business, the Schmid family, and they're still privately owned. My understanding is, and they basically are a tool manufacturer. They make equipment, special handling equipment, plating equipment, processing equipment for everything from solar cells to semiconductors to printed circuit boards. But they've also developed, my understanding, when I saw them at the last IPC show, they were demonstrating some unique technology. I think Gene referenced it, where they can manufacture actually buried circuits. Their process can use a circuitry that's like actually trenched and can plate and fill these trenches.
It's very interesting. They can build trenches and traces buried circuitries. It is extremely unique, and you can get plenty of information from the U.S. President Bob Ferguson, who at one time was chairman of the IPC. Again, if you need his contact information, just send me a note and I'll send you his email.
Yeah,
he sent me a ream of data on this stuff, more than I presented in a couple of hours.
Yeah, there's some videos too on their website that I think will show somehow some of their equipment is making this progress. And I think Secor, unless things have changed, they are a printed circuit board fabricator, high end technology in terms of HDI substrates and circuit boards.
Oh, they're also doing UHDI substrates, and they have a number of facilities in China. And they've last year installed their second or third plasma system, which uses the titanium seeding before electrous copper. I suspect is somewhat similar, not exactly the same, but somewhat similar to the Schmied materials.
Any further questions? I'm checking to see if there's any hands up, or again, just unmute and ask the question if you've got something else or comment. Okay. Well, again, Gene, on behalf of HDP and its members and our guest today, thank you so much for a very informative presentation on really what's going on in the world, particularly in the new technologies, equipment, processes, and some of the players. It's been very informative. And again, our sincere thanks.